So essentially, part B is us practicing everything graphically. So using the calculator to evaluate is all that part B is. All right. So when I am telling you to solve part B, we want to make sure that it is our terms with our variables are by itself as much as possible. And then we're going to go from there. So if you look right here, we start off with e to the 2x minus 3 e to the x minus 4. Okay. So the first thing I'm going to do is go ahead and move the 4. Why am I moving the 4? Because it does not have a variable in it. Does that make sense? So I'm going to go ahead and move the 4 by adding 4 to both sides. So now we're left with e to the 2x minus 3 e to the x equals 4. At this point, you do have the choice to factor out the e to the x. By factoring out the e to the x, that means the reason being is that this is two things. Remember, if I have this multiplied, means I have e to the x twice. But it doesn't save us anything. It says it's all going in the calculator. I wouldn't even waste our time factoring anything else out. Does that make sense? You can if you want to, but is there any reason? No, it's not. So at this point, this is going to be my y1. This is going to be my y2. And the goal here is to find the what? Intersection. Let's go back to our handy dandy calculadora. I'm going to refresh my page. So I have E, shift, and again, I use parentheses just because it makes me feel secure that they're not going to cross mingle. It may not bother you. So okay. And I need this to equal what? 4. I come over here and see where does it equal 4, and it says, oh, we're equal to 4 right here. Such hard work for you. Oh man. Again, is there any reason why you should be getting these wrong? No. No, I will be very angry if my report comes back and the ones on the calculator part that are solving, you get wrong. We're going to. Yes. All right. So again, our goal here, before we do anything, we need to get our exponents by itself. What do I do to get exponents by itself here? There we go. You're going to multiply both sides by 2. So I'm going to multiply u by 2. And I'm multiplying u by 2. So we're left with e to the x minus e to the negative x equals 16. All right. You could combine them if you would like, but do you have to? Nope, because it's going straight into the what? Calculator. Why waste your time condensing? If you choose to, I won't be mad at you, but I just don't think you should. I do for logs though, just because I don't like how it looks. It's like more typing and I don't want to type all that unnecessary stuff. I'm not going to lie to you. All right. So again, come over here. I'm going to type in y equals e to the x minus e. And again, I like to safeguard my multi-factors. So that one's in there. And lo and behold, is just a what? And we got to make sure you put y equals 16. If you do not put the y equals for your numerical value, it will not graph it. I'm going to zoom out. And as you can see, it's a pretty just almost curved line, slightly curved line. At first, you may think it was linear, but it's not. And bam. We get that it's approximately 2.776. All right. Still with me? Questions, comments, concerns about calculator? All right. So let's talk about logs. With logs, could you in theory just type them out as they are? Yes, you could. In theory. But I will encourage you to condense first. And the reason why I encourage you to condense is because it's less error of you, less chance you make an error. And also sometimes it solves itself out. Like it kind of like, and it's like, oh, that's the answer. And you're like, oh, I'm done. All right. So looking here, we have natural log of 3x minus 2 plus natural log of x minus 1. I can condense this through the product property, correct? Product property says that this becomes 3x minus 2 times x minus 1 equals natural log of x squared on the power rule on the other side. So it may ask you, how would it set up or how would you set it up? And so this would be your setup. Now that you have a log on both sides, all you're focusing on are the arguments. All you care about now is the arguments. And for your arguments, you have 3x minus 2 times x minus 1 equals x squared. So when I keep going, I end up with 3x squared minus 3x minus 2x plus 2, which gives me 3x squared minus 5x plus 2 equals x squared. So it just essentially became a what now? A quadratic. And with my quadratic, I end up with 2x squared minus 5x plus 2 equals 0. So you're solving to see where quadratic crosses the thingamabopper. But notice that this doesn't have a calculator thing on it. So it brings you back to remember, how do you solve a quadratic? By factoring this bad boy. Okay. So when you're like, oh, I can put it, nope. Look, if it doesn't have a little calculator symbol, that means that it's a skill that you should already have, which means that we all should be able to factor a quadratic of any form. Okay. You can use the quadratic equation. You can use whatever your heart tells you. We're going to practice and remember the quadratic equation intentionally. That's why I'm doing that instead of factoring. Because even if you suck at factoring, guess who's going to always be your friend? The formula. You know, if you have it in you and you want to sing along with me, hit it. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. That got really ugly with the voice and the writing. But you know what I meant. Okay. If all else fails, use your quadratic formula. And that's because, again, if you're not strong at factoring, it's your catch-all. So x equals negative b, so negative 5 plus or minus the square root of b squared minus 4ac divided by 2a. Now, I cannot vouch if I wasn't your teacher, but as your teacher, I do know you learned the quadratic formula. And I do know that we used it, and I do know that we sung it. So there's video evidence of me sounding horrible all over the internet of me singing it for you. All right, so we evaluate this. So this gives us x equals 5 plus or minus the square root of 25 minus 16 all over 4. What's 25 minus 16? What'd you say? 9. And what's the square root of 9? 3. So 5 plus or minus 3 all over 4. That means that you have two answers, two outputs. I'm going to run out of room, so I'm going to squeeze it in. 5 plus 3 is? 8 divided by 4 is? 2. 5 minus 3 is? 2 divided by 4 is? 1/2. So you have x equals 2 and x equals 1/2. Should I assume that they both are real? And one is not. Which one is not real? It's the half. And why is the half not real? Because if I go back to the original and I plug in the half, what happens here? It becomes a negative. So this is an extraneous solution. So that's not my real, that is my extraneous. And that's because it would make that negative. So be mindful of that again when you are solving. Logs are going to, unless it's like a squared log, that's because you only can intercept, it's a one-to-one function. So you cannot hit it more than once if it's a one-to-one function, right? And that's why it has the inverse of exponential. Because I'm only a one-to-one. I only have an inverse if I am a one-to-one. And that's why it ends up happening. So this is my real solution. Is x equals 2. X equals 1/2 is my extraneous. All right. So I want you to condense and solve by hand. Okay. You can use Desmos and check your answer, but you're going to condense and solve by hand. Go. Your hint is you're using the exponential. Good. Okay, so on this one, how did you condense it? Product. So you get log base 3 of x times x minus 8 equals 2. Now, because there's only a log on one side, that's where I gave you the hint that you would have to use the exponential. And the exponential would be 3. We're going to raise both sides to 3. What I do to one side, I do to the other. So this cancels out. And we're left with x squared minus 8x equals 3 to the 3 squared, which is 9. So you're left with x squared minus 8x minus 9, not equals 9. I feel like I left y'all with the easy one. Okay, so you're asking yourself what multiplies to give you -9, but adds to give you -8? A -9 and a +1. So your solutions here are x equals 9 and x equals -1. Which is the real solution? It is 9. This is your real. And the other is your extraneous. Okay. The last part of this note is a word problem. Because you know, FRQs, where does it come into play? So this essentially is a calculator problem. And it says you have deposited $1,000 in an account that pays 6.5% interest, compounded continuously. Going back to Algebra 2. Okay, you can find the balance in your account using the formula A of T equals ... equals 1,000 e to the 65,000th times t. Use this formula to find the time required for the balance of your account to double. So you're trying to double your amount. So you're looking for when will A of T equal. All right, so A of T equals 2,000. So we're going to have 2,000. So we're going to have 2,000 equals 1,000 e to the 0.065 t. We're going to divide by 1,000, divide by 1,000, and we're going to be left with 2 equals e to the 0.065 t. Okay. Now that we're down to here, we're going to take natural log of both sides. So I'm going to take the natural log. I'm going to give myself some room up here. So I get natural log of 2 equals natural log of e to the 0.065 t, which now means that these are going to cancel each other out because they equal 1. natural log of 2 equals 0.065t. Now to get t by itself, we're going to divide by 0.065, 0.065. So our exact value of t is t equals natural log of 2 divided by 0.065. We're going to plug that in the calculator to get our approximate value. We just go ahead and open up Sylvie really quick. So our approximate value, we end up with natural log of 2 divided by 0.065, and we get 10.664. So that's how long it would take for it to double at the rate that it's growing. Okay, 10.664 years. Right? Now it says, explain the meaning of the inverse function in this context. So if I wanted to be able to figure this out continuously, like how long would it take for me to do something, I would want to have to do this over and over. So instead, I would want to find the inverse of this function. To find the inverse of this function, you can leave it. Just provide the desk. So we're going to find the inverse. For the sake of us finding the inverse without a bunch of excess, we're going to go ahead and switch our x's and y's, our independent and dependent variable. We're going to use y instead of a of t. So we're going to let this be our y. And so when we switch, we end up with t equals 1000.065 times y. Okay. And now our goal is to get y by itself. So essentially, what is my rule and what is my function that I'm following to get y by itself? Well, the first thing that we did was we took the natural log of both sides. So we took the natural log of t. I think I wrote that wrong. We did not do that. You heard me say nothing. I forgot my whole e in there, y'all. We divided. E. First thing we did was divide by 1,000. So we divide by 1,000. And we're left with t divided by 1,000 equals e to the 0.065y. Okay. After we divide it by 1,000, you could either at this point use the power. We're going to use natural log. I said power. We're going to use natural log. So we're going to take the natural log of both sides, and we get the natural log of t over 1,000 equals natural log of e 0.065y. This is going to cancel out. And now we're going to be left with natural log of t over 1,000 equals 0.065y. Last step here to get y by itself is to divide by 0.065y. So we're going to divide by 0.065, divide by 0.065. Now that our y is by itself, this is our inverse because we have now gotten y by itself. So our a of t is going to give us, this is now what we're working with. So we end up with, you can write it like this. You can write it as a decimal, however you want to write it. But essentially, we just need to write it in a way that it makes sense for the rule to follow. So we have 1 over 0.065 times the natural log of t divided by 1,000. And that would be our inverse that we would follow. So now, anytime I'm asking, how long is it going to take for me to accrue this amount of money? I now am plugging that in and figuring out how long it's going to take without having to do the same steps over and over. Now that I have that function to follow, I can now create a model. So now you can graph that, compare it, and then find a of 1,500. And that's what you would keep doing in sense of solving this problem. If you look at the next one, it is another problem of us approximating. It's all calculator. So using approximation, a table to approximate the values is what this is. And so finding what the values are, watching them build up, just deciding on the interval and rounding. And so this is all that piece is. It's just how to approximate so that you can narrow it down. And then last is just making sure that you understand what we're doing. So this is kind of like your exit ticket, your check. Can you get this by itself? Can you find a solution algebraically and graphically? So if you can do this, you're golden. If you can't do this, then please come see me in tutorials. You're awesome. Thank you. And sorry for the background noise. I wanted to try to finish the video. All right, go be great.